Okay, so this is going to be a video on AZ notation, which is just a notation used to specify what particles a nuclide or nucleus is made of. The definition of a nuclide is just an atom with a specific number of protons and neutrons, which is actually quite similar to the definition of an isotope, which I'll talk about later. The only real difference is there's a greater emphasis on nuclear properties rather than chemical properties. And so in physics, you often will hear nuclide used instead of isotope, but it's really just jargon. And personally, I tend to use the word isotope more. Here we've got the general form of AZ notation. We have the X in the center, which represents the chemical symbol. So this is what you see in the periodic table, which are the one or two letters which represents the element. So like for example, capital H represents hydrogen. Next we have the proton number, which is represented by the letter Z, and this is just the number of protons in the nucleus of the atom, just as it says on the tin, the proton number. And from the previous video, I said the proton number is unique to each element, and so the periodic table actually orders elements according to their proton number. What this means is that the proton number is not actually necessary if the chemical symbol is given, and so sometimes you'll see the atom or nuclei represented without including the proton number, and you'll just see the chemical symbol and nucleon number, and that will fully specify all the particles which are in the nucleus. Finally, we have the nucleon number. From the last video, you may remember the definition of the nucleon as a proton or neutron in the nucleus. The nucleon number, which you'll sometimes also see it as referred to as the mass number, is just the total number of protons and neutrons in the nucleus of an atom. This is actually not what's used on the periodic table, unlike the chemical symbol and the proton number. What's used on the periodic table is actually relative atomic mass, and that's actually slightly different. So from the proton number and the nucleon number, you can calculate the number of protons, neutrons, and electrons in this atom. So quite obviously, the number of protons comes from the proton number, and then next, the number of neutrons comes from this formula, which is the nucleon number minus the proton number. So this is quite obvious from the definition, where you're minusing the number of protons and neutrons in the nucleus of the atom by the number of protons, and then so you'll just end up with the number of neutrons. I find it quite common in physics, where if you verbalize the thought process, it's much easier to get to the answer, and so I advise you to memorize these definitions word for word. And I've actually made a list of the definitions for each of the topics, which are available through the link in the description. Finally, the number of electrons will equal the number of protons in an atom, and so you just set it equal to the proton number. With ions, it's a little different, but still quite easy to do. Negative ions will have gained a certain number of electrons, and this number of electrons will equal their charge. And positive ions will have lost a number of electrons, and this will also equal their charge. And so you have to add electrons for negative ions and minus them for positive ions. Here's quite an easy example where we've got helium-4, and to find the number of protons, it's just the proton number, so that's just equal to 2. To find the number of neutrons, represented by the letter N, we just do 4 minus 2, which is the nucleon number minus the proton number, and we get the number of neutrons. So 4 minus 2 is equal to 2. We've got helium-3 here. The proton number is not given, but because it's helium, we can see that the proton number will be 2. And as before, we do the nucleon number 3 minus the proton number 2, and that will equal 1 neutron in the nucleus of helium-3. The definition of isotopes are atoms with the same number of protons, but a different number of neutrons, and so these will be isotopes of helium. In my opinion, the best way to learn is through practice, and so here are 2 isotopes of chlorine, and also a zinc ion. And I want you to calculate the number of protons, neutrons, and electrons in each of these species. So I suggest you pause the video now and try yourself before I go through the solution. Okay, so firstly, we've got chlorine 35, and immediately from the proton number, we can tell the number of protons will equal 17. Since it's an atom, we can also just write down the number of electrons is also equal to 17. And then for the number of neutrons, we do the nucleon number minus the proton number. So 35 minus 17, that's equal to 18. With chlorine 37 now, the number of protons, is also equal to 17, and number of electrons also equal to 17. The number of neutrons is nucleon number 37 minus proton number equal to 20. And finally, we've got the zinc ion with the number of protons equal to 30. Now, with the number of electrons, we have to take into account that it's a positive ion, and so it has lost some negative charge and therefore lost electrons, and we find that it's lost 2 electrons because it has a 2+ charge, and so the number of electrons is just 30 minus 2 equal to 28. And then finally, do the number of neutrons as we've done all the rest beforehand. It's nucleon number minus proton number, and that's just equal to T4.